Now that we've covered hinge joint colliders, we're now going to cover spring joint colliders. So first we're going to duplicate the hinge joint. Move it a bit. Turn off the cube. Turn off the first hinge joint. And we're going to name this spring joint. Remove the hinge joint. Remove the rigid body. And the circle collider. And we're going to change the sprite. What we're going to do is make it a platform. And to do this, we're going to be using the default UI sprite. As you can see, it looks very, very small. We can mitigate this by editing the scale. Alright, we're going to put a box collider. Edit it if you need to. And now we're going to add the spring. I'm going to add a component. Spring joint 2D. Like what we did with the hinge joint collider, we're going to be going over this one by one. So first is enable collision. Initially, the spring joint doesn't let the box collider collide with the ground. Enabling collision basically lets it collide with the ground. The connected rigid body is basically to have it as a point of reference and give it more tangible gravity. This is rarely ever used except in specified situations. You may notice, unlike the hinge joint collider, it looks like it has two different anchors. Regular anchor, like the hinge joint collider, is the main anchor. The main anchor is basically the pivot point, and the connected anchor is more of the pulley this time. Except unlike the hinge joint collider, it's much more visible in the scene view. Auto-configuring the connected anchor basically puts the connected anchor right at the center. It's mostly used as a quick shortcut. Editing the anchor is like editing the platform's center of mass. If you move it lower, like what we're doing here, it's going to be rotating. Too often, pretty hilarious results. And editing connecting anchor is basically editing the position of the pulley, the main anchor that's holding the entire platform. Distance allows us to edit the length of the spring/chain. Example, if I stretch it out a bit, while the platform itself is in the middle, it's just going to drop. And with it a little above the ground, it really looks like it's dangling. Auto-configuring distance puts the spring front and center, just like auto-configure connected anchor does. And it changes the distance value. Damping ratio slows down the movement. And you can only do it in a range of 0 to 1. So let's move the distance. It's going to drop regardless, but it's going to slow down the movement. For point of reference, let's set it back to normal and see it again. Much faster and much more smoother. Frequency also edits the speed, except the limit is 0 to 1 million. Obviously, if you overdo it, it's going to be hard to see. So let's put something more manageable for reference's sake. And break force, just like with hinge joint, once it reaches a certain point in the force, whether through the player or physics, it's going to break. So let's set it to 20 this time. Breaks just like the hinge joint. So with the spring joint explained, let's have it as a platform. We are going to move the connected anchor a bit more up. So distance, make sure it aligns. And let's do this. Oh, I forgot to turn off the brake force. But first, let's edit the anchor a bit. Make it a little more compact. Let's close up the distance. Set brake force back to infinity. Don't want it breaking easily. Now, as you can see, it's pretty easy to fall off. We can make it balanced if we really wanted to, but we could also make it easier by constraining the Z rotation in rigid bodies. There we go. It's just a very, very bouncy platform. And with brake force, we can make it into a platform that instantly falls down the moment you touch it. And again, this is just scratching the surface on what spring colliders can do. In the next video, we're going to be experimenting more with hinge joints and spring joints. For example, having spring joints as a hazard.